There are many problems when you're applying the fundamental theorem of calculus that require that you know trigonometric exact values. So we're going to do a quick review of how to do trig exact value and then do two integral problems that would use those numbers. Okay, so the first thing we want to go through and do is we want to review our quadrants, and the acronym is F.T.O.C. All students take calculus. That's you guys. All right, so all things are positive in quadrant 1. Sine is positive in quadrant 2, tangent is positive in quadrant 3, and cosine is positive in quadrant 4. And then we're going to be doing everything with exact values, so we're dealing predominantly just with the 30, 60, 90 and the 45, 45, 90 triangles. So if we go through and label those, the 30, 60, 90 has a leg of 1, a hypotenuse of 2, and a leg of square root 3. And then the 45, 45, 90 has two legs that are both 1, and the hypotenuse is square root 2. Okay, so we're going to go through and we're just going to refill in this chart with sine, cosine, and tan so that you have it for all of the regular exact value angles. You are going to be responsible for being able to do trig exact value for both the reciprocal functions as well, cosecant, secant, and cotangent. Okay. So let's start with the pi over 6. We'll go back in and fill in the zeros in a minute. So pi over 6 is the same as 30 degrees. So when I look at the 30-degree angle, sine is opposite 1 over hypotenuse 2, so that is 1/2. Cosine of a 30-degree angle is adjacent square root 3 over hypotenuse 2, so that's square root 3 over 2. And then tangent is opposite over adjacent 1 over square root 3, which is radical 3 over 3. Okay. Now I'm just going to skip down to the pi over 3 because that's 60 degrees, and we'll keep working with the same triangle. So now the sine and cosine values end up just swapping spots because we're looking at the opposite angle. So the sine of 60 is square root 3 over 2. The cosine of 60 is 1/2. And then when I look at the 60-degree angle, opposite is now square root 3 over adjacent 1. This is square root 3. Okay. Now if I take a look at the 45, 45, 90 triangle, that's the pi over 4. So the sine of 45 degrees is 1 over square root 2, or root 2 over 2. Cosine has the same value. Tangent is opposite over adjacent again, which is 1 over 1, so that's just 1. Okay. And then the 0 and the pi over 2, the 0 and the 90 degrees, we're going to get by picturing the graphs of sine, cosine, and tangent, or at least sine and cosine, and then doing sine divided by cosine to get tangent. So the sine of 0 is 0. The cosine of 0 is 1. Tangent is sine divided by cosine, so 0 divided by 1 is 0. And then if you're still picturing the sine graph and the cosine graph, the sine graph at 90 degrees has a value of 1. Cosine has a value of 0. Tangent, therefore, is undefined because it's 1 divided by 0, sine divided by cosine. So this is undefined. Okay. So now let's take a look at two examples of how to go through the fundamental theory of calculus that are going to use these exact values. All right, so problem number 3, continuation from the previous video. So we're going to find the antiderivative of sine theta plus cosine theta, and then we're going to evaluate it over the interval from pi over 6 to pi over 3. Okay, and what I have written over here in red is our little reminder. Going down this list would be derivatives, and going up this list would be antiderivatives. Okay, so the antiderivative of sine theta is going to be negative cosine theta. So we're going to have negative cosine theta here. Then the antiderivative of cosine theta is positive sine theta, so plus sine theta. And we're going to evaluate that from pi over 6 to pi over 3. And following along with what the theorem states, we plug in the upper bound first, the b value, pi over 3, and then we plug in pi over 6 afterwards. So the first part is going to be negative cosine of pi over 3 plus the sine of pi over 3. And then we're going to subtract from that the negative cosine of pi over 6 plus the sine of pi over 6. And now we need to know our exact values. So if you take a look at your chart, the cosine of pi over 3 is 1/2, so this first number is negative 1/2. And the sine of pi over 3 is square root 3 over 2. And then we're going to subtract from that the negative cosine of pi over 6. The cosine of pi over 6 is square root 3 over 2, so this is negative square root 3 over 2. And then plus the sine of pi over 6, that's 1/2. Okay. Don't forget to distribute the negative sign. So this guy right here needs to get distributed. So what we really have now is we have negative 1/2 minus 1/2, so we're going to have negative 1. And then square root 3 over 2 minus negative square root 3 over 2 is 2 square root 3 over 2. So our final answer is really negative 1 plus the square root of 3, or you could write square root 3 minus 1. Either way is fine. So this would be our final answer. You do not need to give a decimal answer here. All the trig problems you want to stick with exact value answers. Okay, problem number 4. Now we want to do the antiderivative of 3 cosecant x cotangent x. And we are going to evaluate that over the interval from pi over 2 to 3 pi over 4. Alright, so cosecant x cotangent x is one of our antiderivative rules. The antiderivative of cosecant cotan is actually negative cosecant. So the antiderivative here will be negative 3 cosecant of x. And we're again evaluating from pi over 2 to 3 pi, over 4. That got a little messy. Okay. So we're going to plug in the 3 pi over 4 first, and then the pi over 2 second. That negative 3, I'm just going to keep it out in front, and then I'm going to multiply it in at the end. And you can do this whenever you have a constant times something. So I'm going to do the cosecant of 3 pi over 4 first, and then subtract the cosecant of pi over 2. And then I'm going to multiply the whole thing by negative 3 afterwards. So, cosecant is related to sine, so I really need to know what is the sine of 3 pi over 4, then do the reciprocal of that, and do the sine of pi over 2 and do the reciprocal of that. So if we go through those values, the sine of pi over 4 would be square root 2 over 2. And because 3 pi over 4 falls in quadrant 2, it stays positive. Okay, but we need the reciprocal of square root 2 over 2. And that's just the square root of 2. If you go back and look at the 30, 60, 90 in the 45, 45, 90 triangle, it'll help out a little bit with this. This is the 45, 45, 90. And that's 1, 1, square root 2. And if I look at, say, this 45-degree angle, sine would be 1 over square root 2, so cosecant is square root 2 over 1. That's where the square root 2 is coming from. And again, 3 pi over 4 falls into quadrant 2. So it would be a positive value for cosecant. And then the cosecant of pi over 2, the sine of pi over 2 is 1, and the reciprocal of 1 is still 1. So this is minus 1. Okay? Now I can't combine the square root 2 and the negative 1 together because they're not like terms. One's a radical, one is not. So to get my final answer here, I just need to distribute the negative 3. So you can write negative 3 square root 2 plus 3. Or you could write 3 minus 3 square root 2. And that's your final answer there.